look at the application of normal distribution. So the first example here, the US Navy required that fighter pilot have height between 65 inches to 80 inches. Mean height are normally distributed with the mean 69.5 and standard deviation is 2.5 inches. So you have to read every word. So the key word here is mean height are normally distributed. So it's normal distribution. The mean, all right, the mean. In this case, they didn't talk about sample, so it's mu. All right, mu or the mean, and the mean always go to in the center, 69.5. Again, standard deviation. Again, they didn't mention anything about sample, so it's sigma. So this one is sigma for population standard deviation. Find the percentage of men meeting the height requirement. They asked you to find the percentage, which means they want you to find the area under the curve, which means they want you to find the probability or area under the curve. So the requirement is between 65 inches to 80 inches. 69.5 is in the center, so 65 is to the left. I say somewhere to the left, and 80 is to the right, and the area would be in between. Alright, so that's normal distribution. In order for us to find the area under the curve, we have to convert it to standard normal distribution. Standard normal distribution, also bell shape, area under the curve is 1, and then the z-score is on the horizontal, 0, 1, 2, 3, -1, -2, or -3. And the formula to convert from x, this is your x here. This is your x, and this is your z or z-score. The formula to convert from x to z is x minus mu divided by sigma. Now, because you have two x, you have to apply the formula twice. The first x is 65, the second x is 80. So you have to apply the formula twice. So let's do the 65 first, right? So 65 minus 69.5 divided by standard deviation, which is 2.5. When you calculate this, you want to have 3 decimal places and use the third one. If it's 5 or above, you round up the second one. If it's 4 or below, you just leave it. So basically you need two decimal places. I calculate this, I have -1.80. -1.80 is somewhere here, almost -2. So -1.80. I'm going to use the second x, which is 80. So 80 minus 69.5 divided by 2.5. I calculate this, it's turned out to be 4.2. 4.2 is way past 3. So 4.2. So that's the area in between. So you need to find area, because area in between, I show you from 6.1, you're going to find to the left of -1.8, to the left of 4.2, and subtract the small one from the larger one. In the table A2, I think the number go up to z-score 3.5, so 3.6 all the way to 4.2 will equal to 3.5. Right? So for the area, we're going to have 0.9999 minus 0.0359, which is 0.964, or 96.4%. So 96.4% of all men meet the requirement. That's pretty good. All right. Now let's look at the second part. If the Navy, well, I probably won't qualify, unfortunately. Look at the data. So let's look at the second part. If the Navy changed the height requirements so that all men are eligible except the shortest 3% and the tallest 2%, what are the new requirements for men? So shortest 3%, this 3% is the area. All right, area, the shortest is to the left. So it's very small. We don't know the z-score, but I'm going to convert 3% to decimal. So it's 0.03. All right. Now the tallest 2%, tallest is to the right, the shaded area to the right, 2%. So again, I'm going to convert it to decimal. So basically, they want you to convert from standard normal distribution to normal distribution. So when you convert, you're going to use the same formula, z equal to x minus mu divided by standard deviation. I just move things around to get my x. So x equal to z minus z times standard deviation plus mu. So you're going to end up with 2x here. 1 will be x over here, let's call x1, and 1 will be x over here. Alright, so you have to apply the formula twice. Before that, you have to find the z-score here. So you're going to use table A2, look in the body for 0.03 or 0.0300 or something that really close to that. If you do that, you're gonna get C1, I'm calling C1 here, it's gonna be negative 1.88. Alright, then I'm gonna plug in here to get my x. So I'm gonna have x equal to negative 1.88 times standard deviation, which is 2.5. plus mu is 69.5, and it's turned out to be 64.8. So the number here is 64.8, which is anybody who shorter than 64.8 will not be accepted. So I will not be accepted even for the new requirement. I will not be accepted. So anybody shorter than that will not be accepted. Alright. Now I have to find Z2 here. Z2. Alright. There are two ways to do this. I need to erase this a little bit. Just I need some room. So we talk about 2% here. Alright, one way to do this, you can subtract this from 1 and then get 0.0800 and use this number to find the z-score from table A2, which is 2.05. That's one way. Alright, because they give you the area to the right, you want the area to the left, you subtract it from 1 and then use that to find the z-score. Another way, you can take advantage of a symmetry. You look for the left for 0.0200 or something close to that. The z-score should be negative 2.05 because of symmetry. The right hand side area 0.0200 will be the same but positive. Alright, it's going to be positive 2.05. Either way, you're going to get the same number. So 2.05 for the z-score, and then I have to calculate the x. So the x would be 2.05. Standard deviation is the same. Population standard deviation is the same. Population mean is the same. And if you calculate this, you should get 74.63. So anybody taller than 74.63 will not be accepted. I don't know why too tall will not be accepted, but they will not be accepted. Alright, I'll see you next time.